In this lesson we're going to look at esters. Before we look at their structure and properties, it's best to look at how they are prepared. So esters are prepared by reacting carboxylic acids with alcohols. And this is a reversible reaction which takes place in the presence of a concentrated acid, such as concentrated sulfuric acid, which acts as a catalyst. Okay, and what we'll do is we'll take a specific sample, for example the reaction of ethanoic acid, which is another name for vinegar, with ethanol, which you'll find in wine, for example. Okay, so the structure of the ester is going to look like this. We're going to take, first of all, the ethanoic acid, okay, and that's going to form the ethanoate group. The hydrogen goes over there for a minute, and so this is the ethanoate group. Let's write that here. And then the alkyl chain, that's the hydrocarbon chain from the alcohol, in this case it's the ethyl group, joins on to the oxygen of the ethanoate group. So let's just change that. It sounds a bit complicated, but you'll see what I mean once we've put this in position. So what I'm going to do is I'm just going to change this alcohol around a minute. We're going to remove the OH from there. That's going to join on with this hydrogen here to form water. So let's do that now. So we've got water, and then we'll just swap that hydrogen around here like that. It's still the same alkyl group, but in reverse. And so this joins on to that oxygen there. Okay, so in this particular case there are two parts to the ester. There's the ethanoate group, that's this bit, and then there's the ethyl group, which is this hydrocarbon chain which joins on to the oxygen. Okay, so this is the ester, and the name of the ester is, as is depicted here, ethyl ethanoate. Okay, so in the naming system the alkyl goes first, so it's called ethyl ethanoate. And as with the alkenes, with the alcohols, with the carboxylic acids, we can say that the esters have a functional group, and the functional group is this C double bond O group in the middle. Okay, so this is the functional group. Okay, and we'll write that COO. Okay, so to help us understand this a little bit better, supposing we want to synthesize or produce an ester called, for example, butyl propanoate. What substances will be used to synthesize this ester? Well, as we've just mentioned, the alkyl group comes from the alcohol, so in this case we would use butanol, while the propanoate group comes from the carboxylic acid, so we would react butanol with propanoic acid. Let's just have a look at that. Okay, so we've got propanoic acid and we've got butanol. Okay, so this group here again is the propanoate. That's 3 carbons this time rather than 2, and the alkyl is the butyl group. Right, so we've got butyl propanoate, and of course I didn't have room to fit it in here, but we've also got water. Right, so let's just put that H2O there. So we've got butyl propanoate plus water. So let's just quickly look at the physical and chemical properties of the esters. Firstly, they are colourless liquids. As you've already seen, they are quite large molecules, so there are largest surface areas involved, which means larger intermolecular forces, which means that they are liquids at room temperatures, but they do tend to have low boiling points, which means that they evaporate easily, which makes them quite volatile, and they are also inflammable, so they will burn easily. That's really a chemical property rather than a physical property. Okay, so that ought to be in the chemical properties. And also they are, unlike the alcohols and the carboxylic acids from which they are made, they are not very soluble in water. Okay, so those are the key physical properties of the esters, and the key chemical properties, well, they're really characterized by this, that they smell nice. Okay, so that's their key property. So you'll find esters, for example, present in flowers. That's what gives flowers their lovely smell. And for example, well, perfumes come from flowers, so perfumes and aftershaves or whatever will be made from esters. Now, those esters might be synthesized in a laboratory artificially, or they may come naturally from flowers, the petals of flowers. So let's just make a note of that. They are sweet smelling, they have sweet smelling aromas, and they are also used as flavorings. So not only do some of them smell nice, but they also taste nice. Okay, so you're going to find esters used as flavorings for sweets, and in drinks they're what give various alcoholic drinks their characteristic smell and taste. Okay, so chemical properties: smell nice, sweet smelling aromas, used as flavorings.